we are basically going to do more of biostat. I can later give some few information on bioinformatics so that you read to add knowledge. So let's see the definition. We say biostat is what? It's a statistical method that are applied to biological, medical, or public health data. Statistical method or application of statistical tools or methods in the field of public health, medical, or biological data. What is bioinformatics saying? It's the use of computational tools and algorithms to manage, analyze, and interpret biological data. So this one focuses on biological data. This one is about medical, biological, and public health. Now focus. The biostat involves study design, data analysis, interpretation of health and biomedical data. So here, data analysis, data interpretation, and the like, even the study design, they all constitute biostat. But when you go to bioinformatics, you're talking about the storage of the data, how to retrieve, the analysis of large-scale biological, then data. And biostat, we have clinical trials, we have surveys, we have epidemiological data, and we also have public health data. When you go to bioinformatics, it's talking about genomic, proteomic, transcriptomic, and molecular sequence data. These things are way, I don't know. I think that we have to rename the course to be biostats, the bioinformatics for those who want to do a little more programming. And biostats, we use SPSS, you can use R, you can use SAS, you can use Stata, even Excel, you can use. But when you go to bioinformatics, you have the Python, you have R, you have the Perl, the BLAST, and the GenBank. What skills do you need to do biostats? You need statistics, you need probability, you need business. But when you go to bioinformatics, you're talking about programming languages, databases, and we are talking about large data. Application for biostats, disease risk. We can use it to estimate probability or a risk posed by a particular disease. We can use it to do trend analysis or the risk analysis. We can use it to analyze treatment effectiveness. We can use it also for population health studies. But when It's talking about gene sequencing, mutation analysis, drug discovery, evolutionary studies. Now, when you come to biostat, the data can be small, it can be large. But when you go for bioinformatics, it's highly interested in very, very large data size, not the small, small ones. At the end of the day, what are we expecting? A valid conclusion from biostats. You study the data, you analyze the data, you get conclusions, or you arrive at conclusions and maybe predictions. And it can also serve as an evidence for policy making and evidence for, decision making in general. This one is just to understand the biological mechanism at the molecular and genetic level. So you agree with me that you need the left-hand side more than the right-hand side in your field. That is why I was saying maybe they have to rename the course. The same thing in a different language. It deals with the collection, analysis, and interpretation of health and biological data. This one deals with what? Storage, analysis, interpretation of biological data using computers. And here is talking about statistics, mathematics to study disease and health outcomes. Here, computer science and programming with biology. Biology has become the bedrock here. Here is commonly applied in clinical trials, service, and public health studies. Here, biology is still the bedrock, under which we have the genetics and genomics. Yeah. So here, biostats, SPSS, R, Stata, SAS, etc. Bioinformatics, the big one, we talked about it already. So it is for decision making, policy formulation in healthcare. And here, understanding the genes and the protein, molecular processes. In summary, biostats focuses on how to design studies and analyze health data to make valid conclusions. The bioinformatics focuses on handling and interpreting complex biological data using computational approaches. So that's one thing we couldn't talk about last week. I updated the slides with those ones. Then I think towards the end too, there's something there. You all have this already. So it's the same thing I'm going through. Yes, this is another one. Application of addressing some health research problems. So in pregnancy, you can find what is the average BMI at trimester pregnancy. BMI, I hope you all know that, body mass index. You can use biostats to research on that. Does systolic BP vary significantly by sex, education, and marital status? You can use biostat to investigate that. To research on this, and you'll be able to find out whether the systolic BP of anybody differs based on the sex of the person or based on educational background of the person or based on the fact that the person is married, not married, divorced, etc. Biostat can help you do that. You can also use it to find if there is an association between smoking and low birth weight among women. So when a woman smokes before she gets pregnant, what will be the outcome? When another doesn't smoke and get pregnant after delivery, what's the outcome? I mean, Biostat can help you find out if there is a relationship between a woman who smokes and the birth weight of the baby that will be born. Yes, a minute. Hello? Okay. And you 10 kama moja ga. Mala online class at 10 kama. Okay, later. Tabi? Kayo Ken bo. Kayo Ken bo. Kayo Ken. Okay, let me come. Yeah. Sorry on that. It's a call I was expecting earlier. So the distribution of long-lasting insecticide net, is it effective in reducing malaria prevalence? You can use Biostat to investigate that by way of collecting your data. Is there a relationship between cancer treatment and survival? So if you have various cancer treatments, uh, depending on the type, I think we have chemo and some other things there. Is there, if depending on the type that is used, what is the survivor? What is the expectation of um, I mean, what is the probability of surviving depending on the type or the cancer treatment that is given the patient? Biostat can help you do that. Is there any association between quality of life and socioeconomic status of chronic kidney disease patients? Yes, so the quality of life, whether there is a relationship between the quality of life and the economic status of those battling kidney disease, you'll be able to find out. Is biostat that can be used to do that. Um, yeah, this one we talked about it. Percentage frequency. So it's 18 over the total frequency. The frequency of the case divided by the total frequency times 100. And that gives you the relative frequency or frequency percent. So with the two examples, you should be able to know how we got the 24 and the 30. And when you add all the percentages, it should sum to 100. If you get something apart from 100, there's something wrong with your calculation that you have to check on. So there's another example here, which I'm sure you'll be comfortable with. Another one is here. Okay, it's the same thing. We started talking about. So if you are to construct a grouped frequency distribution table for this data, um, what do? I think we already looked at it the other time. So you choose the classes, you sort, or you do tallying. You count the tally, and that gives you the frequency, and you display the results in a chart or table form. So we were talking about the calculating class width, and I told you that we'll do it better today. Now the class width, we said, is a difference between the upper and the lower boundaries. The difference between the upper and the lower class boundaries. So the upper class boundary minus lower class boundary gives you the width of the class. There's another way of explaining it. When we get there, I will explain to you. Now, for you to know the number of classes that your data set should have, we say K represents the number of classes. These things is just to help you in case you have a set of data you want to analyze and you don't know how to go about it. I'm not going to ask you how to do this calculation, but you need to know. So we are saying to get your K, that's the number of classes, is 1 plus 3.32 log n base 10. Logarithm of n to base 10. So what is n? N is the total number of elements in the data set. So when you look at the data above, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 1, 2, 3, 4, 5, 6, 7, 8. So there are 10 data elements, 8 times 10 data elements here. That gives you 80. And it's even in the question here, 80 college students. So you have to construct a group frequency distribution of the data below, which is amount of time in hours that 80 college students devoted to leisure activities during a typical school week. So 80. So your n here is 80. So you just repeat the formula. K equals 1 plus 3.32 log 80 base 10. Anytime you have logarithm without a base, the base is automatically 10. If you write a log without indicating any base, the base is 10. So the log 80 base 10, you can find it on your calculator. Now life is easy. Gone were the days you have to do some gymnastics to get a value of this log 80. We even had a table or a book called four-figure table that you can go and read this log from. But now life is comfortable. Even when you go online and ask what is log 80, you should be able to get it. So you repeat the same thing. Log 80 is 1.9. So when you manipulate this, you say you are getting 7, which means that the various classes you should have should be about 7. It's not hard and fast something. If you calculate it, you can decide to make it 8. You can decide to make it 6. No one will take you on. the way you do it for you to be flexible. The only thing is the formula should give you a hint. So if you have that data, you can't have a class of 3, you can't have of classes to be 4, you can't have number of classes to be 12, 15, etc. Your analysis may not be too good, or you may waste time needlessly. Now, you calculate the range. We already said the range is what? The highest value in the data set minus the lowest value. So when you go to the data here, you said the highest value is 38, I think it's here, and the lowest value is 10. So when you subtract, you are getting 28. So you are now going to divide that 28 by the number of classes, which is 7. So here too, when you divide 28 by 7, you are getting 4. There's no problem if you make the size of your the width of your class to be 5. There's nothing wrong. And what this means exactly, I will explain it very soon. You can, when the need arises, run up to the nearest whole number. You approximate to the nearest whole number. So the same exercise has been done here. Same exercise has been done. Okay, so we already looked at this one. So you have the data there. When you see 23, notice that (23) belongs to this range. So you put a stroke, a straight line. You go back, you cancel this one out, you go for 24, you tally it there. 24 also belong here. You tally it. You do it like that for all of them. They will belong to each of these. Then I told you that when you get a 5th one, you use it to cross. So all these are 5, 5, 5, 5, 5. So for you to count, this is 5 plus 3. It gives you 8. This is 5 plus 5 plus 5 plus 5 plus 5. That's 5, 5, 25 plus 3 gives you 28. 5 times 5 plus 2, 27. 5 by 2 plus 2 gives you 12. And this is 4, this is 1. When you add all these frequencies, it should give you the same 80, which were talked about in the question. The same 80 which was talked about in the question. Yeah, hello. Good evening. Yeah, my online class started 3. I will even be closing very late, so let's make it tomorrow morning. I normally sleep late. I don't know about you. Okay. Okay. Well, sorry about that. Yeah, so you should get the same 80. Then when you find your cumulative frequency, the last one, which is 80 here, should be the same thing here. If you don't get the same 80 here, it means there's something wrong. So you begin to mark yourself in advance before you even hand over your paper. Okay, let me talk about the class width. The class width, this one. Or you can also see it in some books, class size. This one, we are saying is the difference between the upper and the lower class limits. Which we calculated here, and we are supposed to use 4. But this one is saying a width of 5. You can construct whatever. So I told you if you have 4, you can adjust it upwards 5. There's nothing wrong. You have to be comfortable. Now, when I ask you what is the size or the width of the class here, 10 to 14, all that I'm asking you, how many different numbers can be tallied under that class? How many different numbers can be tallied there? So we have 10 itself, you have 11, you have 12, you have 13, and you have 14. So there are 14 different numbers that can be tallied under or in that class. That gives the width of the class or the size of the class. So the size of this class is 5. It's the same as to subtract the lower class boundary. The lower class boundary, we say we subtract 0.5 from 10, and that gives you 9.5. For the upper class boundary, you add 0.5, so that gives you 14.5. So when you subtract 9.5 from 14.5, you are going to get the same 5. You are getting the same 5. When you subtract 29.5, if you have 29.5 and you take away 24.5, you are going to get the same 5. All of them. It's a uniform class. So the class size, class width remains 5 for all of them. I hope this makes sense. I don't want you to be thinking too plenty. When we say class width, class size, that's all we are talking about. Any confusion? I hope I'm not alone in this class. Let me see. Okay. I already talked about midpoints. No need to worry about it. A class boundary. So I was telling you that to find a class boundary, you take the upper class limit here. The lower class limit here. You add the two of them and divide by 2. You find their average. And that will give you 0.5. Another way of doing the same business is to take the lower class limit here and subtract the upper class limit. 30 minus 29, that gives you 1. That gives you 1 before you divide by 2. When you divide by 2, you are getting the same 0.5. Note that at your level, the class sizes may not be the same. So if the class size are not the same, you can't get this 0.5 and be adding and subtracting, adding, subtracting, adding, subtracting. You have to do what I'm telling you for each of them. You add this and this. You divide by 2. Whatever you get, you add it to this one, which is 29.5, and subtract from the left side. That gives you 19.5. So all the left sides, you are subtracting. You are subtracting from all the left side. But the right side, you are adding. So once again, if the class size is not uniform, you have to do the same thing for all of them. But this one, we have uniform class size. So the moment you get your 0.5, add to the right side, subtract to the left side, and you are gone. So all that we are talking about in summary is the fact that to find class boundary, you add 0.5 here, subtract 0.5 here. For class midpoint, you add 10 and 19. That gives you 29 and divide by 2. And that gives you 14.5. You do same for all of them. You can equally add this and divide by 2. You get the same answer. You get the same answer. So if you have this as your frequencies, the cumulative frequency, the first one will repeat itself as 5 there. Then you add 19 to 5. That gives you 24. You add 10 to 24. You have 34. You add 13 to 34. You add 47. You add 4 to 47. You have 51. You add 4 to 51. You have 55. You add 2 to 55. You have 57. So you have 57 here. Your last answer there should be the same thing here. Now, relative frequency. So you take the frequency and divide by the total frequency. So that's 5 over 57. And you multiply by 100, and that gives you 8.8%. You do for 19 over 57 times 100, 33.33. You do for all of them, you get the same answer. So if I were you, when you go home or when you have little time, this is how you learn. You just try copying this table again. Then you bring this column, the width. Then you don't bring these ones. The next thing you can bring is the frequencies. Then you try to find your own class boundary. You find your own class midpoint. You find your cumulative frequency. Then you find the relative frequency. If you're able to do that correctly, then you know that learning has taken place. We do not read. Calculation, we do not read. We practice. Your eyes can be deceiving you. You'll be reading. You think that before you realize nothing has entered. Nothing has entered, and it's during exam that you get to know that your brain is empty. So you practice, don't read, practice. Now, so this relative frequency is what we use to draw a pie chart. So I'm going to talk about pie chart briefly, then we go on. Any questions so far? Any question? Confusion or convincing? Is anybody here? Okay. I can see some reactions. Yeah, Lucia, you want to ask a question? Lucia, is it Ellis? Go ahead with your question. Okay. Um. Oh, okay. Okay. I got it. I got it.
All right, that's better now. Yes. Okay, thank you. We were told in our last class that we needed to have a calculator for this course. Could you please recommend what kind of calculator we would need? Is it a
Fine.
scientific calculator, or what would be the best kind, or the simplest one that would be user friendly?
That's fine. That's a
Did you
nice
hear
one there.
me?
Yeah, I heard you right. I hope you can
Okay.
also hear me. Yeah,
Sorry.
okay. So I think it's scientific calculator, not programmable calculator. Scientific calculator. And
Okay.
I think Casio FX991ES also on
Okay.
that.
Could you
Yeah.
please post that in the chat, because or post it somewhere, because right now I'm mobile, I'm moving around, so I won't be able to take notes. So could you please put it in the chat?
Okay, class rep. Let's give that assignment to class rep. I want to be double sure of the name before. I'm currently in office, so
Okay.
let me get home
Okay.
and check on the name so
Yes,
that
please.
I will let you have it.
Please, yes.
So
And my other question is about the
you can
the
equally pick my number and send me a WhatsApp message,
okay, I
and
can do that. I will do
I
that.
will be home before or by
Yes.
12 midnight. I'll
O-
be home.
Okay, I will do that. The other question for me, this is a challenge. I did statistics years ago, and I am following you, but it's a bit complicated. So what would you be providing us with um, cases where we can apply, or do we need to research for ourselves um, statistical data and practice how to manipulate it using this information that you are giving us?
you and Happy New Year.
The same to you.
Okay, all right. So yes, so at this point,
You're welcome, bro.
yeah, so at this point, you should assess yourself. Either you end at where you are as a naturopath, or if you want to because but if you want to be a naturopathic doctor, there's no curve. There's no shortcut.